Okay, so now we're going to do something along the lines of linear equations, but now we're going to solve rational equations. And rational equations means that there are unknowns in the denominator, the bottom part of a fraction. It sounds kind of scary, but it's really not. So we've got a strategy to solve them, which we'll go over. Then it's really not bad at all. So this first problem that we're given is 3 divided by x plus 4 minus 7 equals a negative 4 over x plus 4. Now, one way we could do this, since we've got fractions in the denominator, is we could change this minus 7 to a minus 7 times x plus 4 and divide it by x plus 4. But an easier way to do it, since we want to not deal with fractions if we can avoid it, an easier way to do it is to multiply both sides of this equation by x plus 4. And that'll also take care of the fractions by eliminating this part in the denominator. And I'll show you that. If we come down here and we say x plus 4, and we'll put that in parentheses to remember that we've got to multiply the whole thing by that. And then we multiply this side of the equation, 3 over x plus 4 minus 7 equals, and remember we've got to do the same thing to both sides of the equation here, so x plus 4 times x plus 4. Now when we multiply by fractions, and we're multiplying by both of these statements here, this x plus 4 term will cancel out with this x plus 4 term here. So x plus 4 times 3 divided by x plus 4, that will cancel out, and we'll be left with 3. And then what we'll have here is a minus 7 times x plus 4. And then on the right side of the equation, this x plus 4 term will cancel out with this x plus 4 term, and all we'll have left is 4. So now we've gotten rid of the fractions, and then we can attack this and solve it just like we would for a linear equation that we did before. So first thing we want to do is multiply this minus 7 times both terms here. I'm sorry, you got to watch this. I have trouble with this still. It's a minus 4 is what the original equation was. So we've got to come back in here, okay, minus 4. So 3 minus 7 times x plus 4 equals a negative 4. So 3 minus 7x, negative 7 times a positive 4 gives us a negative 28 equals a negative 4. Now 3 minus 28, that'll give us a negative 25, so we'll get 7x minus 25 equals a negative 4. Now, just like we did before with linear equations, which is what this is now, we add 25 to both sides of this equation. We'll get minus 7x equals a positive 21. And then we can divide both sides of this equation by a negative 7, so we can isolate this x, and that'll give us x equals negative 3. And that's our only solution. So what we have to do is go back to our original equation and make sure that there aren't any, that the value of x that we found is an actual solution. If x were a negative 4, then there would be no solution, because what we would end up with is 3 divided by a negative 4 plus 4, which is 0. Well, anything, we'll go ahead and write that out. If x were 4, a negative 4, excuse me, then we would have 3 over negative 4 plus 4, which equals 3 divided by 0, And 3 divided by 0 is indeterminate. Anything divided by 0 you can't find. It's indeterminate. So if x were negative 4, then we would have no solution. But since x is negative 3, that's what our solution is. X equals negative 3. Okay? So the second problem that we were given is a similar type of thing. 2 over x minus 3 minus 4 times x plus 3 equals 8 over x squared minus 9. Now again, what we want to do is eliminate these unknowns, these x's, in the denominator of all these equations. And we do that by multiplying times the lowest common denominator, which is this x squared minus 9 term here. And if you might recognize this as x squared minus 9 is a difference of squares. And we can rewrite this whole equation as 2 over x minus 3 minus 4 times x plus 3 equals 8 over, and that'll be x plus 3, x minus 3. And we can see that the difference of squares is simply, if you have any kind of generic term here, if you have an a squared minus a b squared, well, in this case we have a as an x squared and b would be 3, 3 squared is 9, then that can be factored into a plus b, a minus b, and that's the difference of squares. So this x squared minus 9 term can be factored to x plus 3 and x minus 3. So now we can multiply both sides of the equation by this x plus 3, x minus 3 term. So we can come over here and say x plus 3, x minus 3, and we'll put that in brackets just to make sure that we multiply it by everything on the left side of the equation. 2x minus 3 minus 4x plus 3 equals 8 over x plus 3, x minus 3 times x plus 3 times x minus 3. So, come in here again. This x minus 3 term will cancel with this x minus 3 term. So we'll be left with 2 times x plus 3. This x plus 3 term on the bottom here will cancel with this x plus 3 term. So we'll be left with a minus 4 times x minus 3. And over on the right side of the equation here, this whole thing will cancel out. So we'll be left with 8. So if we multiply this out, now we've got a linear equation, just like we solved before. So if we multiply this out, we'll get 2x plus 6 minus 4x. Minus 4 times a minus 3 is a positive 12. And that's equal to 8. So 2x minus 4x gives us a negative 2x. 6 plus 12 gives us 18. And that is equal to 8. So now, if we subtract 18 from both sides of this equation, we'll get 2x equals a negative 10. And then if we divide by a negative 2 on both sides, we'll get x equals 5. Now, just like before, we've got to go back up to our original equation here and make sure that we don't have anything that gives us a 0 in the denominator, and we don't. So our solution is x equals 5. And if we wanted to, we could just plug that in and check that. So 5 minus 3 is 2, so that goes into, that 2 divided by 2 becomes 1. Then we'll have 5 plus 3 is 8, so minus 4, so that becomes a 1/2 here. So 1 minus 1/2, that equals 1/2. And then 5 squared is 25 minus 9, so that's 16. So that gives us 8 over 16, which equals 1/2. So 1/2 equals 1/2, so that checks out. So again, that's rational equations, solving rational equations. And the way that we do that is by finding the common denominator to get rid of all these unknowns in the denominator. And by doing that, then that becomes a linear equation, and then we can just solve it like we would any other linear equation.